Right, this is for maths when we were looking at transposition and stuff like that. I'm just going to show you this in my paint because I've got a touchscreen device at the minute. The example we used in class was if 5 people contribute the same amount each to buy you a gift or whatever, and it's £100, how much did each person contribute? Now if you can answer that, you're already good at transposition, because the method that you've just done in your head to work out the answer is exactly transposition. We've got 5 people gives £100. We don't want to know what 5 people have contributed. We know that it's 100. We want to know what one person's contributed. So to work that out, of course, we'll do 100 divided by 5. And what we've done mathematically is we've taken the times 5, taken it over to the other side, and as soon as it crosses the equals sign, the sign reverses. So times becomes divide, plus becomes minus, and squared becomes square root. That's about all that you can get thrown at you, more or less. You could have cubed and then cube root, but that's about it. So by taking 5 times across, becomes divided by 5. So how much has one person, if you like, contributed? It's going to be 100 divided by 5. You could write divide by 5, that's fine, whatever, it's the same difference. So 100 divided by 5, you know that one person has contributed £20. Mathematicians and engineers love abbreviating things. They won't put apples, they'll put A, that kind of thing. Yeah, everything, you could say it's laziness, it's efficiency. Consequently then, let's transpose some more things. So if that is transposition, you're just rearranging formulas around to get the term that you want on its own. There is a knack to it, but it's straightforward. So let me undo this. In fact, I'll just, I'm using a touchscreen pen, you see, so I'll just move across. Oops. Let's consider this example then. The above one, you could solve it because there were numbers involved. In this case, there are no numbers involved, right? So we'll have AB equals C. You're probably thinking, that's mental, you can't solve that, it's just letters. To a certain extent you're right. You're just going to use this as an ability to prove to people that you can manipulate things around. So for instance, using the above example, you could say, if you like, the above example is effectively 5p equals 100. It's the same format, if you like, as saying AB equals C. You've got A, you've got B equals C. It's the same method. I know that the values are different, but the method's the same. So on that tack, we could say then, just rub that out. To find B, let's say in this example, so we're looking for B, I'll put B in brackets over here. At the minute, when you see 2 letters together, AB, that's the same as A times B, because mathematicians can't even be bothered to write times. So to get B on its own, in the same way that we took times 5 across, if we take times A across, we'll be left with B equals C, and then the times A becomes divided by A. And that's it. That can't be solved anymore. The above answer, you can't work it out and get an answer of 20. This is, you can't work this out numerically, you've just got to leave it as a load of jumbled up letters. Let's try another example then. Let's try AB plus C equals D. In this case, when you use things like BODMAS and BIDMAS, if you're not familiar with that, that's fine, just it'll come to you. The term attached to the A, let's say in this case we want to get A on its own. The A has been times by B, and then you've got C added on at the end. The easiest term to get rid of first is this plus C, because it's not tied to the A, sorry, as strongly as the B is. The B's been multiplied, the C's been added. It's further away from it, if you like, in mathematical terms. So to get rid of plus C, we'll take that over, and it's going to become minus C. So we're going to have AB equals D, because that's already there, so that has to stay there, minus C. But we still haven't got A on its own yet. It's still been times by B. So we're going to take times B across and get divided by B. So we're going to end up with A equals, and D minus C is already there, so D minus C stays there, and because it was there first, it all gets divided by B. See? Let's do another quick example, show you the shortcuts. If you had something like A times B times C equals D, seeing as they have been multiplied, it's the same as saying 1 times 2 times 3 equals, and in this case we could work it out. 1 times 2 is 2, times 3 is 6. Using that example, that's a numerical solving, right? In this example, A times B times C, it's unsolvable. There's no numbers, so we're going to have to keep it as letters. What we'll do is, we can actually just crop this off and move it all across. It's been times at the minute, and it'll all get divided. So we're going to end up with A equals D, and then we've moved B and C across together. So B's been times by C, so at the bottom B's been times by C. We've just grabbed that whole term and moved it over. Now in the example before, we worked out 1 times 2 times 3 equals 6 in that example. So if we put those numbers into this and worked out what A would have been, we know that we started with A as being 1, B has been 2, C has been 3, and we calculated D as 6. In this case, if we put it in that formula, we should end up with an answer that equals A, which we worked out as 1. So let's see if that's true. Well, D is 6, so D is 6, then divided by BC. B is 2, times by C, which is 3. So 6 divided by 2 times 3, that's the same as 6 divided by 6. In effect, it's saying how many 6's are in 6. That's 1. So we've just proved that that transposition there is the correct way to rearrange that original sum there. Where is it? That one. Sorry, I'm miles away. That one. That one's been rearranged correctly into that, and we've proved it using numbers. Let's do something slightly more awkward. Let's have something simple like A squared equals C. In this case, let's put numbers in. We'll leave A squared equals, and we'll say 25. To work out what A is, we'll just do A equals, and then take the squared across, becomes square root of 25. In this case, A would equal 5. In this example, however, it's unsolvable, because we haven't been given 25, we've just been given a letter C. But it's the same method. So all you're going to do is take the squared across, and you're just going to be left with A equals square root of C. The reason there's certain lines appearing now and again is because I'm on a wobbly touchscreen device and my finger's catching the screen. Right, let's do something slightly more complex. Let's have AB divided by C plus D equals E. In this case then, the easiest thing to get rid of, in terms of the weakest link if you like, well, plus is always weaker than times and divide. AB divided by C equals E, well, we take plus D across, it becomes minus D. Right? Next stage, we're not there yet. We're trying to find A, by the way. Next, we're going to take this divided by C across, because it's always nice to have things on one line. So if we take divide C across, it's going to become times C. But everything that's already there has to be times by C. And there's a way we're going to have to do this. So we'll put AB equals E minus D, and then all of that times C. But that's not written correctly. That looks like it's only D times by C. Because E and D were there already, originally, you'd have to bracket that and say, right, work that out first, and then times that answer by C. Otherwise, it's wrong. So that were there first, so that gets bracketed to show that it was there originally. An easier, neater way of writing that is AB equals C, and then just put brackets E minus D. That's the neat way of doing it. But we still haven't got A on its own yet. We've still got this times by B problem. But of course, we can overcome that problem, because times by, when you take a times across, times B, is going to become divided by. And because all of that is already there, all of this is already there, it's all going to get divided by B. So in this case, we're going to be left with A equals C, effectively times by E minus D. And then it's all already there, so we're taking B across, so it's all going to get divided by B. That's more or less how it works. If you wanted to put numbers in to check it, you could give A a number, B a number, C a number, D a number, work out E, and then put in what you got for E, what you used for D, what you used for B, what you